Hello everyone, I welcome you all in this course Introduction to Sequence Stratigraphy, and as part of our discussion on the different types of systems tract, we will be continuing our discussion on the high stand systems tracts. So, in the last lecture we have seen that the high stand systems tract, they are commonly represented across the entire basin starting from the fluvial part to the marginal marine and shallow marine and then into the deeper marine part. But when we look into the self and deep marine part, there the representation of the HST is very much monotonous, commonly represented by hemipelagic to pelagic mud deposition, commonly represented by condensed sections. So, that is a very low energy monotonous condition, not much of variation in terms of processes, not much of variation in terms of energy. So, definitely we do not require detailed discussion about that particular condition. In the last class we have already discussed about that. So, I will not go into that part again. But in the last class we have discussed about the fluvial component, as we have seen in our previous lecture, that the major changeover, major processes are confined into the fluvial to marginal marine part of the basin during the HST. And there we can see that the fluvial system, it aggrades, it shows aggradation and progradation, and that results in formation of a delta in the river mouth area, in the shoreline area, and that delta can lead to strand plane. And this entire delta and the strand plane system, they show aggradation and progradation. So, the variation that occurs in terms of the fluvial processes, fluvial depositional systems, that we have discussed in our previous lecture. So, to continue with that lecture, to continue our discussion, in this class we are going to discuss about the delta system that will form during the HST part, where we can see the delta plane aggradation and the delta front progradation. So, this HST part, we see a continuous regression process, and during this continuous regression process, under this very high water level condition and very high rate of sedimentation, we commonly expect that the shallow marine portion of the high stand systems tract, it commonly is represented by single upward coarsening upward facies succession, and these coarsening upward facies succession produced by successive clinoforms which are prograding with aggradation. So, they will downlap the lower bounding surface, which is the maximum flooding surface. So, on this maximum flooding surface, as the delta system is prograding, so delta clinoforms, they will gradually downlap over this maximum flooding surface. So, in terms of the shallow marine portion of the high stand systems tract, it commonly display a coarsening upward facies profile, and that coarsening upward facies profile is produced by relatively low rate of progradation associated with aggradation under a normal regressive condition. Now, this high stand prism, as we have discussed in the previous lecture also with the diagram, we have discussed that the high stand prism that forms, so it can form from the fluvial system, and as the fluvial system is gradually prograding into the marginal marine part, that high stand prism can be traced within the delta part as well, delta depositional system as well. So, this high stand prism typically includes deltas, and within such delta we commonly expect topset geometry which can be produced in clastics dominated settings, or we can even observe them in a carbonate depositing setting, in a carbonate platform setting. So, that delta plane area, which is the topset geometry of any delta, it commonly shows more aggradation than progradation, and that results in the formation of this high stand prism. So, if I want to understand this delta plane aggradation, that is the topset part, and the delta front progradation in little bit more detail. So, it is a kind of little bit complex high stand regression process. So, we can understand this with a simple diagram. So, let us think of a river system which is part of the delta plane, and this river system is reaching to a delta mouth area, river mouth area, where it is debouching the sediments, and those sediments are getting deposited over here as delta front lobe or delta lobes. So, in section it is like the delta plane followed by the delta front and then the pro delta area. So, this is called as the top set part, this is the delta front and this is the bottom set or the pro delta area. So, when we are looking at this part, that means this particular area, there the river accommodation space, as we have already discussed in the last class, the accommodation space initially is very high, and that is why the river system will try to aggrade at higher rate than progradation. So, in this delta plane area, what we expect? Successive delta planes will get aggrading like this, and as the delta plane is aggrading, they are supplying the sediments over here at this mouth area. So, that will lead to the formation of a delta plane. So, we will get the accumulation will be like this. So, overall the system is prograding forward, as well as in this part it is more of aggradation than progradation, whereas when I am looking at the delta front area, in this part it is more of progradation with aggradation. Now, in this kind of scenario, as we are reaching to the maximum height, say initially the water level was here and then finally it is reaching up over here. So, this kind of scenario can be expected at the initial phase, maybe up to this. But when we are reaching over here in this portion, there the accommodation is decreasing, or rather it is not increasing as in the rate as it is required with respect to the rate of sediment supply. So, as in case of fluvial system we have seen, here also we will get a crunch in the accommodation available, we will get a competition in terms of accommodation available, in terms of consuming the accommodation, and as a result of that, when it will be reaching towards the top part, the delta planes, they will be more thinner and the delta fronts will be much thicker. So, it will be like this. So, in this upper part we get this kind of scenario where more of progradation is going on, because now the vertical aggradation is not that much available and we are getting less amount of aggradation, higher amount of progradation. So, within this delta plane part we get more aggradation, that is the top set area, and that is resulting in this area which is called as the high stand prism. So, this high stand prism continuing from the fluvial part, it will continue into the delta plane area. Whereas, when we look into the delta front area, there we get progradation, but initially the progradation will be associated with aggradation, but as we are moving into the upper part of the HST, if this is the entire HST package, then in the upper part of the HST, we get more of progradation with less of aggradation. So, this is the complex high stand regression that we expect within the delta system during HST phase. So, these packages of this delta front and delta plane, their migrations, their building up, that is commonly controlled by high frequency TR pulses, high frequency transgressive regressive pulses. That means within the major HST we can get smaller pulses of falling and rising and falling and rising of the base level, resulting in small scale or higher frequency transgressive regressive cycles. And that kind of frequencies results in the fluctuation in the rate of sedimentation, and that fluctuation will control the thickness of the clinoforms formed during this aggradation and progradation process. So, in the shallow portion of the high stand systems tract, we can observe that there is a succession of stacked prograding lobes, where individual lobes they extend further seaward relative to the previous one. So, this further extension of the individual lobes one after another, that is representation of this fluctuation in the sediments and the base level condition at that particular time. So, what we get over here, a forward stepping or a seaward stepping pattern of the basin fill, as I have shown you over here in this diagram. So, gradually it is like individual units are gradually progressing forward and they are covering up. If this is the overall basinal condition, so basin is gradually getting filled up. So, forward stepping basin fill pattern. So, that will be the characteristic during the HST, particularly during the end phase of the HST. During the initial phase of the HST, we also get the same kind of pattern, but here the filling pattern is more upward than forward. It is more of upgrading rather than forward stepping. Forward stepping will be only confined over this delta front area. So, a forward stepping or seaward stepping pattern of the basin fill is characteristic of the HST, particularly when we are looking into the delta system. During the early HST phase, when we are getting aggradation more than progradation, the degree of vertical overlaps of the progressively younger prograding lobes is more pronounced. So, in that case, individual prograding lobe, that will be more overlapping in nature, and that overlapping will be more vertical overlapping. So, when it is the early phase of the HST, so in that phase what we are getting more of this kind of vertical overlapping of the delta lobes. So, if I think of this particular lobe, so the next one is like this, the next one is like this. So, more of vertical overbuilding than less amount of forward overbuilding. Whereas, when we look into the late phase of the HST, the thickness of the topset package, which reflects the degree of vertical overlap between successive prograding lobes, it decreases with time, resulting in more of progradation than aggradation. So, in such cases, what is happening over here, the vertical lobes, they are more prograding, like this, not vertically aggrading. So, we are over here in this kind of scenario where the vertical aggradation is relatively less. So, vertical overlaps are relatively less, and individual delta lobe progradation, it is not showing vertical overlap, but they are showing forward overlap, forward stepping pattern. So, this is the characteristic in terms of delta depositional system during the HST. So, with time, the prograding delta lobes, they will try to fill up the available accommodation. So, as the accommodation is gradually getting filled up, the available space is getting less and less. So, the sediments which are being supplied by the river system, by the distributary channels, they will try to produce the delta lobes, but those delta lobes have less accommodation available now when we are reaching towards the end part of the HST. So, definitely these individual delta lobes, they will become much thinner in a basinward direction. So, as a consequence of this particular process, what you can expect, the more of progradation will be going on, less of aggradation. Now, why these are becoming more thinner? Because the base level, it is rising, the rate of rise of the base level, it is decelerating, and progressively less accommodation is created on the shelf. This will result in a gradual lowering in the fluvial energy during the late phase of HST, and that lowering in the fluvial system, fluvial energy condition, will result in less supply of the coarser grain sediments into the delta front, into the delta plain area, more abundance of the finer grain sediments within the delta system, both within the channel as well as in the interfluve areas as well as in the overbank areas. So, overall within the delta lobes, if I look at the successive delta lobes starting from the bottom to the top, the grain size distribution will be more finer towards the upper part with respect to the lower part of the HST. So, if I want to summarize the distribution of or nature of the delta system during HST, when a delta is progressing forward, we can get two distinct patterns. So, we can have two separate systems. One is the early HST part and we can have a late HST part. So, during the early HST part or late HST part, we can think of three different parameters of the delta system and how they will change. So, if I look at the overall thickness of the delta system, the thickness of the entire delta system starting from the delta plane to delta front. So, during the early HST, the overall thickness will be much thicker. The overall delta depositional system will be much thicker, whereas during the late HST, it will be much thinner with respect to the early HST part. Because in this case, gradually the accommodation available is decreasing, as well as the overall gradient, slope gradient of the river profile is decreasing, resulting in lower energy condition, and that will reduce the supply of sediments. That will reduce the supply of coarser fractions into the channel system, into the delta system. So, definitely the delta lobes which are forming, they will be much thinner. As well as during the late HST phase, the accommodation is decreasing. So, chances of vertical aggradation is decreasing. So, delta lobes, they will try to move forward and try to cover up the basin fill. So, overall thickness of the delta system will be relatively thinner with respect to the early HST phase. Now, if I want to see the second parameter, say in terms of the distribution of the delta system. So, during the early HST phase, the delta system is more confined towards the landward side, the progradation is less. So, it is not that much reaching to the open marine system, it is not that much affected by the open marine system, as the sea level is quite high, the base level is quite high. So, in this kind of scenario, the distribution of the delta system will be much smaller, they will be more localized. So, in terms of the delta system, it will be more localized in terms of distribution, because at that time it will be confined in a small area like this. So, it will be a smaller delta. But as the time is progressing and we are reaching from early HST to the late HST, there the entire basin will be covered up now by this delta system through its progradation. So, definitely in that case the size of the delta will be much bigger and definitely its distribution will be much wider, or it will be much larger in size in terms of its distribution pattern. So, with time from early HST to late HST, we can get a well developed delta during the late HST phase. During the early HST phase, the delta will be forming there, the delta plane will be more developed with respect to the delta front area. Now, the third parameter is the grain size, overall distribution of the grain size within this delta system. Now, during the early HST phase, we commonly expect more coarser grains, abundance of more coarser grains, whereas during the late HST phase, we expect abundance of more finer grains. Why? Because during the early phase of the HST, the river systems, they are bringing lot of sediments. The delta plain area, it is bringing lot of sediments and they are accumulating over there. So, the overall supply of coarser fractions is higher, and also at that time the river profile, river gradient, it is relatively higher with respect to the base level condition. As I have drawn it earlier also. So, initially the river profile was like this and now it is reaching up over here gradually. So, this much of change in the gradient will lead to decrease in the energy. So, at the initial phase of the HST, when the river gradient is higher, definitely it will bring more coarser sediments into the system. Whereas, at the late phase, when the gradient is much gentler, the overall energy of the river system will be much less and it will result in supply of more finer sediments into the depositional system. But if I look into the overall pattern starting from here to here within a prograding delta system, always we get an overall coarsening upward trend, which is a characteristic of any regression. So, we get that overall coarsening upward trend within a delta system. So, these are three parameters in terms of the depositional systems within a delta that forms during the HST phase in the marginal mean area. So, we can get significant changes in terms of the thickness, distribution and grain size distribution pattern within the delta system from the delta plane to the delta front area. Now, in terms of the economic potential, resource potential, when we look into the HST system, we can think of either the occurrence of petroleum or occurrences of coal. So, in terms of petroleum play significance within the HST part, so we can get 4 distinct zones again. We can try to understand this in terms of 4 distinct zones. So, we can think of the fluvial part where aggradation with bit progradation is going on. We can get the coastal part where a delta is forming and definitely the strand planes are forming, they are also aggrading and prograding. We can think of the shallow water part where we are getting dominantly mud. So, it is the shore face to shelf faces where dominantly mud is getting deposited during the HST time, and we can think of the deep water part where dominantly mud is getting deposited. So, in terms of sediment budget, if I try to understand with respect to the petroleum play significance, with respect to the sediment budget, so within the fluvial system, it is an aggrading system. So, it is relatively good in terms of the sediment budget, because there we are getting lot of sand supply, as well as those sands, those channel fill sands, they are capped by overbank muds. So, in terms of sediment supply, in terms of sediment budget, there is a good supply of sediment is also very good. In the coastal area where a delta is prograding and a strand plane is forming and it is prograding, there also the sediment supply is significantly good, as we are getting coarser fractions within the delta plane, within the delta front, as well as they are capped by the pro-delta sediments or the overbank deposits, the interfluve deposits. So, we have a overall good supply of sediments. If I look into the shallow water and shelf area, there also the sediment supply is good, but it is in terms of sand is to mud ratio, the ratio is quite low as the mud supply is relatively higher. And as we move towards the shelf part, the sediment budget is significantly low, which continues into the deeper part as well, where the sediment budget is significantly poor. So, with respect to the sediment budget, if I think of the reservoir quality or the potentiality of reservoir, we can think of the fluvial system. So, there channel fills are there, maybe the crevasses plays are there. So, these channel fills, they are thick sand bodies which can act as good reservoir, but definitely their lateral extent will be limited and they will be abruptly cut by the overbank mud. So, lateral continuity of the reservoir sands will be little bit disturbed over here, which we may not face in case of the delta system, because there the mouth bar sands or the delta plane sands, they will be much wider, much continuous. So, we can get strand plane sand as well, which can be much more laterally continuous and much more thicker. So, in terms of reservoir sand, reservoir quality sand, definitely the delta sand or strand plane sand will be much more preferred. If I look into the shore face sands, if in the shore face area the sand is continuing, sand is coming up over there, there also we can get thick sand, which can be a very good reservoir sand body. But definitely when you are moving into the shelf and deep water part, the overall sand supply will be very poor. So, in terms of reservoir quality, their potentiality is extremely poor. Now, when we are thinking of the reservoir, what we require is the source rock and the seal rock. So, in case of fluvial system, the source materials in terms of the source rock system, they are relatively poor, because the overbank systems, they are not continuous, the overbank depositional systems can act as relatively fair sill, but often it is not continuous, particularly when we are moving into the upper part of the HST. There these sill portions are not very well developed. In the coastal areas, we commonly get relatively poor sill material, poor source material. If I look into the shore face area, we can get some finer materials, particularly the finer materials deposited in the offshore and into the shelf area. They can act as good sill as well as good source materials. Similarly, we are getting pelagic mud or hemipelagic mud in the deep basinal part, in the outer part of the shelf, which can also be a very good source rock or which can act as a very good sill rock. If I try to combine this information, our observations together, so in terms of reservoir condition, in terms of reservoir faces, what we understand from the HST deposit, it is mainly can be confined, mainly can be identified within the proximal regions of the basin. But when we look into the source and sill faces, their potentiality, they are relatively low in the marginal marine part, and for that what we require is we have to look at the distal areas of the basin, where the relatively shallow to deep water environments producing these thick pelagic and hemipelagic mud, they can act as good source and sill materials. So, in terms of overall petroleum play significance, HST deposits are not the best one. They are not the best reservoir faces, they are not the best source and sill faces, but yes, in certain conditions where we are getting good delta mouth burrs or maybe a good channel fill sand, it can act as a good reservoir faces, provided there is a source or sill faces available adjacent to it. Or in other words, in HST condition, mostly in the marginal marine part, we can get a good reservoir rock provided we get a corresponding sill and source rock. If that sill rock is present, if that cap rock is present, we can get a very good reservoir sand formed during the HST in the marginal marine part of the basin. In terms of the coal resources, HST deposits are not good for coal resources. Already we have seen during our discussion on the maximum flooding surface that when we are reaching to the maximum flooding surface, the most significant coal seams, they remain associated with that particular surface, the maximum flooding surface, because at that time commonly we get all the favorable conditions available, like commonly very high groundwater level, vegetation growth, sediment supply, relatively less amount of sediment supply, more organic supply. So, all these factors are commonly fulfilled at the MFS or just after the MFS. So, along this zone we get the best coal resources. As the HST starts, which is associated with decreasing base level rise, decreasing rate of base level rise, that is associated with more sediment supply into the system, more supply of the clastics into the system, and when the clastics are supplied into the system at higher rate, the chance for thick peat accumulation decreases. So, within HST part, maybe at the very bottom part, very lower part of the HST, we can get coal seams, which may be a continuation from the maximum flooding surface. But as we move towards the upper part of the HST, where gradually we are getting more sediment supply, more amalgamation of the channel systems, more development of the delta front and the delta plains, their chances of getting thick coal seams, thick accumulation of peat is very less. So, in terms of coal resources also, we do not expect much thicker coal deposits within the HST system. So, finally, to conclude this entire discussion which is going on for last 2 lectures. So, the HST system which lies between the transgression and the next force regression, that indicates the highest level of the base level, highest position of the base level, during which the rate of base level change is slower than the rate of sedimentation, and in response to that we get a very complex pattern with respect to depositional conditions from the continental side to the entire basinal part. So, that we have discussed with respect to the fluvial system, we have discussed with respect to the marginal marine system, where we can see formation of a delta, its progradation and aggradation, formation of strand plane. And then when we move into the further deeper part, moving into the outer part of the shore face to offshore to shelf, and then beyond that area, beyond the shelf edge, it is an overall stable condition, overall low energy condition without much variation in terms of the depositional processes, producing dominantly pelagic to hemipelagic mud deposits over there. So, these are some of the references that you can go through for further reading. Thank you everyone.